Hi Math to Enhance. This is a video for page 16 and 17 of our packet. So we're going to be graphing quadratics. So y equals x squared is my parent graph. It hasn't been shifted left or right or up or down. So my vertex is at the origin 0, 0. So I put a dot for my vertex. And I remember my quadratic movement is 1, 1, 2, 4, 3, 9. So from my vertex, I move 1 to the right and up 1. And then I also move 1 to the left and up 1. That's my 1, 1 movement. 2 squared is 4. Hence why when I move 2 to the right, I'm going to count up 4. 1, 2, 3, 4. Then I'm also going to go 2 to the left and count up 4 as well. 1, 2, 3, 4. And finally, those 5 points are enough for me. But if you want to put additional points to get an even better graph, you would use 3, and 3 squared is 9. So that's my quadratic movement. So I'd go over 3 and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. You'd go over to the other side and also up 9. This gives you your parabola. Remember to draw this in, not as a V. It's more of a, I'm not drawing very well with my Apple pencil, but it shouldn't look like an absolute value function. It should have a gentle curve to it as much as you can. And this would be my graph. So the axis of symmetry is that line that goes down through the center of your parabola. If I could do a dotted line here, I could fold my red parabola up on this blue line. This line is occurring on the y-axis. That is the vertical line x equals 0. Vertical lines are always x equals a number. In this case, it's always the same as the x coordinate of your vertex. So my axis of symmetry would be x equals 0. My y-intercept is also the origin. And my zeros are also the origin. So let's take a look at an equation in standard form. As we looked at when we did, was it page 13? I believe it was. When I'm in standard form to get my vertex, I can use the handy dandy formula for my x coordinate of the vertex, which is negative b over 2a. So for this particular problem, that would be negative 4 over 2 times 1. That's negative 4 divided by 2, which is negative 2. So what is that? That is the x coordinate of my vertex, as well as the vertical line that I'd be able to fold my parabola up on. So to find the y coordinate of my vertex, I'm going to substitute in negative 2 for x, and I'm going to find out what y is. So let's do that. Y equals negative 2 squared plus 4 times negative 2 plus 3. That is 4 minus 8 plus 3. So it looks like I'm getting a negative 1 for that. So my y coordinate, my vertex is negative 1. So let's go find my vertex. Negative 2 and down 1. Here's my vertex. My a is 1. What's in front of my x squared is a 1. So I'm going to use my quadratic movement. 1, 1, 2, 4, 3, 9. So 1, 1. Ooh, those are going to be my x-intercepts. I just found them. And then 2, 4. So over 2, up 1, 2, 3, 4. Just found my y-intercept. Left 2 and up 1, 2, 3, 4. And you can also do the 3, 9 if you want to. And then softly draw in your parabola. Again, try not to make it look too V-ish. My y-intercept looks like, I can see it right from my graph. I don't need to solve for it. I can see that that's at 0, 3. X is 0, y is 3. My zeros are on my x-axis. Those are my x-intercepts. And I can see that's occurring at what? Negative 1, 0. And it looks like the other one is at negative 3, 0. Now my equation in factored form, I got to factor this guy. And so going back to earlier in class, you could use your diamond method. You've got your 3 at the top, your 4 at the bottom. When I do that, my side numbers would be 1 and 3. So this would become x plus 1, x plus 3. If you need more help with that, please come to office hours. That's my factored form. So now vertex form. Okay, remember from when we did page 13, vertex form is y equals a times x minus h squared plus k. where my vertex is HK. So in this problem, I already know my A is 1. That's what's in front of the x squared. That's right here. That's 1. So I don't need to worry about my A. So y equals, and then x. Now be careful here. The x coordinate in my vertex is -2. That's my H. Notice that there's a negative here. So a -2 actually makes it look like x plus 2. Remember, what's in the parentheses looks the opposite of what my coordinate is for the vertex. Now the k is just whatever k is. So in this case, my k is down 1 or -1. So my vertex form would be x plus 2 squared minus 1. So let's take a look at the next page. At the top, I have x minus 1 squared. In this particular problem, please notice that this is vertex form, that my k is 0 and my a is 1. So my y equals a times x minus h squared plus k. So my vertex would be +1, 0. Make sure when you're looking for your HK, you have to think the opposite of what you see in your parentheses for your x coordinate, and then you write whatever your k is. So let's go find that 1, 0. That's my vertex. So I know my axis of symmetry occurs at the vertical line x equals 1. There's a vertical line going down through the center of my parabola here at x equals 1. And I want to draw in the rest of my parabola. I notice that my a is 1, so I'm going to use my quadratic movement, 1, 1, 2, 4, 3, 9. So let's do that. 1, 1, 1, 1. Oop, I just found my y-intercept. And let me go over 2 and up 4. 1, 2, 3, 4. And over 2 and up 1, 2, 3, 4. And you could do your 3, 9 if you'd like to have a more complete picture of your parabola. And I'm going to draw it in. Again, don't make it look too V-ish. It's not absolute value. I can see my y-intercept on this graph. It occurred at 0, 1, 0, +1. And I only have an x-intercept at 1, 0. So that would be my x-intercept, my zeros, my solutions, my roots. Now in standard form. So in standard form is when it's all multiplied out. Please remember that x minus 1 squared means x minus 1 times x minus 1. So you're going to box or FOIL that. When you get done, if you do it correctly, you should have x squared minus 2x plus 1. If you have any trouble getting that, please come to office hours and I can help you with what you're stuck on. So then let's move down to our last problem in this page. There's a little bit more going on in this problem, putting a lot of things together here. So first of all, this is in vertex form. It's helpful to know the form I'm working with. It helps determine my next steps. So in this problem, I can see my a is 2. That's going to affect my quadratic movement when I get there. I can see that my h is +3 because I think the opposite, and my k is -10. So my vertex is at 3, -10. It's way down here at 3, -10. So my axis of symmetry is going to occur at the vertical line x equals 3. That's the vertical line going right through the middle of my vertex. So now let's graph this. So normally my quadratic movement is 1, 1, 2, 4, 3, 9. But now I have an a that's 2. I'm doubling my vertical movements. My vertical movements are going to be twice as big. If it had been a 3, they'd be 3 times as big. So if it had been a 1/2, they'd only be half as big. So instead of going up 1, I'm going to go up 2. Instead of going up 4, I'm going to go up 8. And if I chose to do my 3, instead of going up 9, I'd be going up 18. So when I go to graph, instead of going 1, 1, I'm going to go 1, 2. And instead of going left 1, up 1, I'm going to go left 1 and up 2. My y values are increasing twice as fast. So now I'm going to do my 2, 8. Over 2, up 8. So 2, 3, 4, 5, 6, 7, 8. Over 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. So a couple things with this. In this graph, I can't accurately see my y-intercept or my zeros, my x-intercepts. So I'm going to have to find them with algebra. Let's discuss how to do that again. So in this problem, if I want to find out my y-intercepts, so my y-intercept, This is when my graph crosses the y-axis. This is when x equals 0. So my plan is to substitute in 0 for my x and solve for y. So let's do that. So I have my y equals 2, and I'm going to plug in a 0 for my x, minus 3 squared, minus 10. So I put a 0 in for my x, and now I've got to solve. So y equals 2, 0 minus 3 is negative 3. And so this looks like it is 2 times a positive 9 minus 10. That's 18 minus 10. That's 8. So when x is 0, my y value is 8. So I'm going to put 0, 8. So up here at 1, 2, 3, 4, 5, 6, 7, 8, this is where my graph would actually cross the y-axis if I had counted carefully, my 318. So now what about my x-intercepts, those roots? That's what we've been solving for, x-intercept. This is why we learned how to solve by factoring, taking square roots of both sides, completing the square, and quadratic formula. So when I want to figure out this is when I set y equal to 0, and I substitute 0 for y, and I solve for x. So this is what we had been doing in class. So in this problem, when I set it equal to 0, I have 2 times, in parentheses, x minus 3 squared minus 10. So I really don't think this is a good candidate for factoring or quadratic formula or completing the square, because this is really set up with only one squared term. This is a good time to solve by taking the square roots of both sides. Remember, in that method, my first step was to isolate my squared term. So let's do that. Let's add 10 to both sides. I get 10 equals 2 times x minus 3 squared. Now I'm going to divide both sides by 2. I'm further trying to isolate my square term, and I get 5 equals x minus 3 squared. On my iPad screen, I'm running out of room, so I'm going to move my problem up here. So now this is where I'm ready to take the square root of both sides. When I take the square root of my 5, I get plus or minus 5. If it's okay with you, I'm going to move it to the right side, just because when we did our problems previously, usually this number was on the right side. When I take the square root of x minus 3 squared, the square root and the 2 cancel, the exponent of 2 cancel, I get x minus 3. And remember, this is when I'm going to move the 3 over by adding 3 to both sides, and I'm going to stick it right in front of my plus minus. So I'm really sorry, iPad students. When I moved my 5, I forgot my square root. Can you pause for a moment? And when I moved my square root of 5 from the left side to the right side, I forgot to put a square root there. Sorry. So now back to the step I'm doing. I'm adding 3 to both sides, and I slide that right in front of my plus minus. And I get 3 plus minus the square root of 5. So that is an answer. Those are my two x-intercepts, 3 plus or minus the square root of 5. However, and that's two answers. It's 3 plus the square root of 5 and 3 minus the square root of 5. That's kind of hard to picture where that's at on my x-axis. So you could grab out your calculator, and there's two answers there. There's 3 plus the square root of 5, and when you do that on your calculator, you should get 5.23 or 5.24, depending on if you round. And I can do 3 minus the square root of 5, which should give me approximately 0.76. So this is the same thing as 5.23 and 0.76. That's a little easier for students to picture that I'm crossing the x-axis just to the right of 5 and just to the left of 1. And you can kind of see that in my rough sketch. It looks like that's about where I was. What's my equation in standard form? So this is when I have to multiply everything out. So in this problem, I have 2 times x minus 3 squared minus 10. Let me go back and rewrite that as a minus 10. So be careful with your algebra. The first thing I'm going to handle is my parentheses. So remember what this means. It means x minus 3 times x minus 3 minus 10. You guys, let's handle my parentheses first. It's x minus 3 times x minus 3. Off to the side, do your FOIL, do your box, gather your like terms. You should be getting for x minus 3 times x minus 3, x squared minus 6x plus 9. If you're not, come see me and we'll work on that part. So now I'm going to handle my multiplication. I'm going to distribute my 2 to each term. I get y equals 2x squared minus 12x plus 18. Don't forget your minus 10 is there at the end. Oh, that's an 18. So gathering up my like terms, I now have a 2x squared minus 12x and 18 minus 10 is plus 8. This is my equation all multiplied out to standard form. So y equals 2x squared minus 12x plus 8. So this is the last 4 examples for graphing that we did in class. If you need some extra help, I'll see you in office hours. Thank you. See you in class.